Welcome back to the deep dive. We're shifting gears a bit today.
Yeah, definitely a change of pace.
Usually we look at broad trends, market shifts or big philosophical questions in the tech world. But today it's a tactical mission.
Get your hard hats on.
Right. We are zooming in on a very specific, very high stakes target. We're looking at the VMware Telco Cloud Automation exam. Codename 5V0-36.22.
It really sounds like a droid from Star Wars, doesn't it?
It really does.
Oh, you're right. This isn't, it's not a casual chat about the cloud in general. This is for the people in the trenches.
The architects, the engineers.
Exactly. The folks who need to prove they can wrestle the massive, complex beast that is modern telecommunications into a sleek, automated platform.
And if you're listening to this, you probably aren't just casually interested.
Yeah.
You are likely staring down the barrel of this exam, or maybe you're trying to figure out if your team has the chops to pass it.
It's not for the faint of heart.
No, it's not. So we have pulled together a stack of practice questions, official documentation, some real-world scenarios. But we aren't just going to read you the answer key.
That's boring. And frankly, it doesn't help when they change the wording on the actual test.
Which they always do. Memorizing answer C is a great way to fail.
Oh, absolutely. We need to unpack the logic behind the answers. We need to understand, why the platform is built the way it is. If you understand the architecture, the answers actually become obvious.
Right. So before we get into that architecture, we have some really meaty questions to get through today. Let's talk logistics.
Let's do it.
If I'm walking into the testing center, or logging in from my heavily monitored home office where I'm not allowed to sneeze without permission, what am I up against? Is this a marathon or a sprint?
It's a bit of a sprint, actually. You have 105 minutes.
Okay, an hour and 45 minutes.
Yeah, and you have to get through 50 questions in that time.
Let me do the math there. That's roughly 2 minutes a question. That sounds generous on paper, but I imagine these aren't simple true or false questions.
Far from it. I mean, some of these are paragraph-long scenarios with diagrams. You have to read the scenario, diagnose the problem, and pick the solution. 2 minutes goes by very fast when you're deciphering a multi-cloud topology.
Yeah, and the pressure is on because the scoring is scaled.
It is. The scale runs from 100 to 500, and the magic number you are looking for is 300.
So if you hit 299...
you are coming back another day.
Ouch. And paying the fee again. Speaking of which, what is the damage to the wallet for this one?
Generally about $250 USD. It varies by region, but that's the ballpark. So failing is a pretty expensive habit.
Definitely. Now, one thing I noticed in the prep notes, the format, it says multiple choice and multiple selection. I have to say, I hate multiple selection.
Everyone does.
The whole choose all that apply thing is just designed to make you second guess everything you know.
It really is the hardest format. It forces you to know not just the main function of a tool, but its secondary and tertiary capabilities too.
I can't just eliminate the obvious wrong answers.
Exactly. You have to be confident in every single correct one. Precision matters here.
All right, so stakes are set. Time is ticking.
Uh-huh.
We've organized our research into 4 main buckets to help you structure your study. We've got the brains, the body, the nervous system, which is all about speed, and the economy.
Sounds like a solid plan. Let's start at the top.
The grains, the orchestration layer, the command center.
Right.
And this brings us to one of the most fundamental questions in the exam material. It sets up a scenario. Say you have a multi-cloud environment. You've got some workloads on AWS, some on-premise vSphere, maybe something on Azure.
Pretty standard setup nowadays.
Right. And the question asks, what is the primary function of the Telco Cloud Automation Manager in this setup?
This is the flagship question. If you don't know this, you might as well pack up and go home.
Well, the options are interesting. You have things like managing physical hardware cooling systems or monitoring power for individual VMs. I mean, I know we call it infrastructure, but are we really expected to be checking the air conditioning?
No, and please, for the love of everything, do not select that option.
It sounds so specific, though.
That is a classic distractor. If you pick the cooling system option, you are applying for the wrong job. You want a facilities management role, not a cloud architect role.
Telco Cloud Automation is software.
Exactly. TCA is software. It doesn't hold a screwdriver.
Okay, so we rule out the janitorial duties. The correct answer, based on the source material, is that it provides a unified orchestration engine for managing services across different clouds.
That's the one.
But let's push on that a bit. Why unified? Why can't I just use the AWS manager for the AWS stuff and vCenter for my on-prem stuff?
You could, and people did for a long time, but it was an absolute nightmare. The key insight here is consistency. If you are a telco operator, you are deploying network functions. Think of them as the actual apps that make phone calls or data sessions work. You need those to behave exactly the same way, whether they are sitting in a data center in Ohio or on a public cloud edge in London.
So you don't want to be writing two totally different sets of scripts for the exact same application.
Exactly. The TCA manager is the single pane of glass. It abstracts away the differences between the clouds underneath. Think of it as the general overlooking the entire battlefield, ensuring the strategy is executed identically everywhere.
Okay, so the manager is the general. But a general doesn't usually radio the specific soldier in the trench to tell them to dig a hole. There's a chain of command.
Precisely. The general deals with strategy, the officers deal with tactics.
Which leads us perfectly to the next layer in our brains section. The next question asks, which component provides the localized interface to the virtual infrastructure manager, the VIM, for resource orchestration?
This is a subtle but very crucial distinction for the exam.
The answer is the Telco Cloud Automation Control Plane.
Right. So you have the manager and you have the control plane.
In plain English, what is the difference? Why do we need two brains?
Think of it this way. The manager, the general, says we need a 5G core network in New York. That is the intent. But the manager doesn't necessarily know the IP address of the specific switch in the New York data center.
And that's where the control plane comes in.
Yes. It sits closer to the infrastructure. It speaks the specific language of the hardware.
So it's the translator.
Exactly. The manager says deploy, and the control plane translates that into, okay, vCenter, I need 50 gigs of RAM, 12 CPUs on this specific cluster, and attach it to this specific virtual switch.
It bridges the gap between the abstract request and the physical reality.
You nailed it. And for the exam, you really need to remember this mapping. Manager equals global and multi-cloud. Control plane equals local and infrastructure specific. If you keep that straight, you'll navigate these orchestration questions easily.
Got it. Manager's global, control plane is local. Now, before we leave the brains section, we have to talk about rules.
The fun stuff.
Well, the IT world is usually pretty Wild West, right? Move fast and break things.
Yeah.
But telco cannot break. If telco breaks, emergency services stop working. Grandma can't call the grandkids.
Right. It's highly regulated and highly standardized. You cannot just make things up as you go.
So there's a question that asks, which organization defines the industry standard framework for NFV, network functions virtualization, that this whole platform follows?
Let me guess the options. The usual alphabet soup.
Oh, yeah. ISO, IE, ETSI, W3C.
Right. So if you come from a web development background, you might guess W3C. If you come from standard electrical engineering or Wi-Fi, you might say IEE.
But the answer here is ETSI, the European Telecommunications Standards Institute.
Correct. ETSI is the Bible for this stuff. They wrote the architectural framework that defines exactly how virtual networks should function.
Even though it has European in the name.
Yeah, despite the name, their NFV standards are the global baseline. If you are building a telco cloud anywhere in the world, you are building it to ETSI standards, period.
So if the exam asks who says so, the answer is almost always ETSI.
That is a very safe bet in this context.
All right, let's move from the brains down to the body.
Yeah.
We know who is giving the orders, the manager, and who is translating them, the control plane. But what are we actually moving around? What is the payload?
You're talking about the package.
Right. There is a specific question about onboarding. When you want to add a new network function to your catalog, you can't just upload a zip file and hope for the best.
Certainly not.
The question asks for the standard package format for onboarding. And the answer is CSR.
Cloud Service Archive.
Now, I've heard people say CSAR and CSAR.
Let's just stick with CSAR to be safe.
Fair enough.
Yeah.
But why does this format matter so much? Is it just a file extension?
It's much more than that. Think of it like a shipping container.
Okay.
Before shipping containers, you had barrels, sacks, wooden boxes. It was total chaos to load a cargo ship. The shipping container standardized everything. It didn't matter what was inside, the crane knew how to lift it, and the ship knew exactly how to stack it.
That is a great analogy.
A CSR file is that shipping container. It bundles the disk images, the resource descriptors, the configuration scripts, literally everything the system needs to know to unpack and run that application is inside that one artifact.
So it makes it vendor neutral.
Exactly. It guarantees that if I buy a firewall from vendor A and a router from vendor B, they can both be onboarded into my system using the exact same automated process.
Okay, we have our shipping container. Now we need a place to put it. This brings us to the clusters.
The destination.
The question asks, in a telco cloud platform deployment, Which cluster runs the actual telecommunications network functions?
This seems obvious, but people trip up here all the time.
The options are things like management cluster, global controller cluster, or workload cluster.
A lot of test takers choose management cluster because it sounds important. They think, well, the critical stuff must run in management.
But the answer is the workload cluster.
Right. And this comes back to that separation of duties concept. You never, ever want your actual revenue-generating services, the phone calls, the 5G data streams, fighting for CPU cycles with your logging software or your monitoring tools.
Well, the management cluster just keeps the lights on. The workload cluster is the factory floor where the product is actually made.
Perfect way to look at it. The workload cluster is where the virtual network functions and cloud-native network functions live. That is the final destination for your CSR package.
Got it. Just one more question in this deployment section. It asks about the life cycle. Say we've onboarded the package. What is the first major step after onboarding?
The options probably include things like scaling, healing, or termination.
And instantiation.
Yeah.
Which is the correct answer.
It has to be. You cannot scale something that doesn't exist yet. Instantiation is just the fancy telco word for spin it up.
It sounds profound, though.
Yeah.
I'm instantiating the network.
It does sound powerful.
Yeah.
But functionally, it's just the moment where the blueprint in the catalog becomes a living, breathing instance on the workload cluster.
It's claiming the actual resources.
Exactly. It allocates the RAM, assigns the IP addresses, and hits the on switch. Until you instantiate, it is just a file sitting on a shelf.
All right, let's get into the weeds now. Section 3. We are calling this the nervous system. This is all about speed, reflexes, and the magic of 5G.
This is the technical deep end. This is where telco cloud really separates itself from standard enterprise cloud.
Because in standard cloud, like if I'm hosting a corporate blog, if there's a 20-millisecond delay, nobody cares.
Right. But in telco, if there is a 20-millisecond delay, your voice call creates an echo, or worse, your autonomous vehicle doesn't break in time. Latency is the absolute enemy here.
So question 5 brings up the buzzword of the decade, network slicing.
Oh, yeah.
The question asks, which 5G technology allows an operator to create multiple dedicated virtual networks on a single physical infrastructure?
And the answer is network slicing. This is the holy grail business model for 5G.
Explain slicing to me like I'm a reasonably intelligent teenager who drives.
Okay, imagine a highway. That highway is your physical fiber cable. In the old days, every car shared the same lanes. If there was a traffic jam, everyone slowed down the ambulance, the sports car, the delivery truck.
Very egalitarian, but terribly inefficient for emergencies.
Exactly. Network slicing puts up concrete barriers on that highway. One lane is only for the ambulance. It guarantees zero traffic. That is your ultra-low latency slice for things like remote surgery or factory automation.
In the other lanes?
Another lane might be 10 lanes wide, just for massive trucks carrying 4K video. That's your high bandwidth slice.
And you are doing this on the exact same asphalt. You didn't build new roads.
Exactly. You are virtualizing the network performance. That's why it's so revolutionary. You can sell a premium fast lane to a hospital and a standard lane to a coffee shop, all running on the same underlying hardware.
But to make those fast lanes actually fast, we need to bypass some bureaucracy in the servers. Which leads to question 6. It asks about a technology that allows a virtual machine to directly access a physical network adapter.
The answer is SRIOV, Single Root Input-Output Virtualization.
Another acronym. Break it down for us. Why do we need this?
In standard virtualization, there is a hypervisor in the middle. It's like a traffic cop. Every packet of data has to stop, show its ID to the hypervisor, get stamped, and get direction.
That takes time.
Microseconds, yes, but they add up fast when you are processing millions of packets a second.
And SRIOV fires the traffic cop.
Essentially, yes. It punches a hole straight through the virtualization layer. It lets the virtual machine see the physical network card directly. It says, I don't need a middleman. I'm plugging straight into the wall.
So you get high throughput and low latency.
Essential for the data plane. If you are moving heavy traffic, you absolutely need SRIOV.
But we can go even faster, apparently. Question 7 asks about DPDK, Data Plane Development Kit. The question asks for its main benefit.
And the answer is that it accelerates packet processing by bypassing the kernel.
Okay, wait. We bypassed the hypervisor with SRIOV. Now we are bypassing the kernel. What is left?
Not much. The kernel is the core of the operating system. It handles everything: mouse clicks, file saves, security checks. But again, that's overhead.
Right.
If you are a network router, you don't care about mouse clicks. You just want to move packets.
So DPDK pulls the networking out of the OS kernel and puts it into user space.
Right. It's like taking a task away from a busy CEO and giving it to a specialist who does nothing else all day long. It eliminates the context switching of the operating system. It's pure, unadulterated efficiency.
Okay, so to recap the speed section for the listener, slicing cars up the road for different uses. SRIOV removes the traffic cop to get directly to the hardware, and DPDK removes the speed limits enforced by the OS.
That is a brilliant way to visualize the stack. If you can remember that hierarchy, you will nail the performance questions on this exam.
Awesome. Let's wrap up with Section 4, the shared economy. We talked about slicing, but there is a broader concept here. Question 10 asks, which feature allows different providers to securely share the same physical infrastructure?
The answer is multi-tenancy.
This feels like the landlord conversation again.
It is entirely the landlord conversation. Telco infrastructure is incredibly expensive. Building towers, running power to edge locations, cooling servers, it costs billions of dollars.
Yeah, you can't just spin that up in your garage.
Right. If every carrier had to build their own separate physical data center for every single edge location, 5G would simply never happen. It's too expensive.
So they share.
They share the building, they share the infrastructure, but multi-tenancy ensures that tenant A has absolutely no visibility into tenant B's apartment.
And this isn't just a gentleman's agreement to not look at each other's data, right?
No, it is hard, logical isolation. It is enforced by encryption and strict resource separation. The exam focuses heavily on this because it's the economic engine of the cloud. Without secure multi-tenancy, you don't have a cloud, you just have a rented server.
That makes total sense. Thanks for listening to this deep dive. Go crush that exam.
Good luck, everyone.